Hello, Keith Rucker here at VintageMachinery.org. Guys, new machine day. Got a new machine for the shop, and most guys out there probably recognize this lathe. This is a Monarch 10EE, which is considered by many to be one of the most accurate tool room lathes that was ever built. These were made by the Monarch company, who specialized in making lathes. They were up in Sydney, Ohio, and Monarch made some outstanding machines. I've got my main lathe over there, my 16-inch Model K, is a Monarch. I absolutely love these Monarch lathes. They were well-built machines and really designed to stand the test of time. And this machine is definitely fits in that category. It has survived the test of time. Where did this one come from? This one, believe it or not, is actually a gift. It's a gift from one of my viewers, Willie Bemis, who is up in New York. And he had bought this machine for his shop, and for various reasons decided that he didn't want to keep it in his shop. One of those reasons being some issues that he found with this lathe, and we're going to be talking about those in a few minutes, that he just wasn't really ready to tackle. And he contacted me and said, hey, I just want to give it to you. I want you to have it, which is a mind blower to me. These are nice machines. These are highly sought after machines. And but anyway, he was kind enough to give me this lathe. But it does come with a catch, and that catch is it does have an issue or two that we're going to be talking about here in just a little bit. But anyway, I'm really excited to have this. I know many of you guys know I do have a Monarch 10EE that I'm in the process of restoring. We've had the bed reground on it. Actually, a friend and viewer of mine has got a lot of the castings on it right now, and he's doing some painting. He's going to actually do the painting and the body work on it, and we're waiting to get that back. I told him I'm not in a hurry, so he's been taking his time doing that project. But at some point in time, we're going to be doing a rebuild project on my other 10EE, and like I said, I've already sent the bed out and had it reground. And my goal there is to really have pretty much a brand spanking new machine. I want to totally go through it and really do it right. It's kind of my plan. This one here, you know, I get into the issues here in just a minute, but this one here mechanically appears to be in very good shape. Very little apparent wear on the ways. Almost no apparent wear on the ways, as a matter of fact. And mechanically, it seems to function just fine. I have kind of run it through its paces. I haven't done any real work on it yet, any kind of testing or anything like that, but just seeing if everything works. Everything does, and we'll show you some of that here in just a minute. So taking a quick look here at the name plate on here, and it tells you some information about it. The catalog size and model. It's a 10EE. Some of these are kind of hard to read. Actual swing on it is a 12.5. It was considered a 10-inch lathe by Monarch, but it will actually swing 12.5 inches. The distance between centers is 20 inches, which is pretty standard for a 10EE. It's got a manufacturer's number on there, 1120. Not sure what that means. The buyer's machine number is blank, and the date built is 1956, so February of 1956. And the cost installed, almost every one of these Monarch badges that I have seen, that is blank, and this one is blank as well. But main thing we've learned from this is a 1956 vintage Monarch 10EE. So one of the interesting things about these Monarch 10EEs is that most of them that were built over the course of the years, up until I think some of the newer ones is a little bit different, but most of these have a direct current or DC motor in them that powers it. And the main reason that they used the DC motors was that it gave you a very wide speed range, but it also gave you very good torque at pretty much any of those speed ranges. With a three-phase motor, yeah, you can put a VFD on them. In today's world, you know, put a VFD on there and have speed control. The problem is that when you get down to those lower speeds, you often lose a lot of torque. The nice thing about these direct current motors was that you pretty much kept your horsepower rating constant throughout the speed range as long as everything was set up properly and everything, it was sending the right voltage and fields to that motor. And I'm not an expert on DC motors. I've been learning a lot about them here lately, kind of after getting this one. And I've also got to tackle some of these things with my other one. Now, when this lathe was new, I believe that this one actually had a bunch of tubes, old antique tubes like you would see in old radios and televisions, early forms of electronics. It had a bank of tubes inside of the cabinet down here on the end that did a lot of the motor control stuff. And basically you would give it, you know, single phase power or three-phase power, alternating current power regardless. You would feed it with alternating current power, and it would convert that over to the direct current, and in a way where your voltage would change and again, the fields and going to it, that motor would change. And I don't fully understand all of it. I'm not an electronics person. A lot of you guys probably know more about it than I do, but by changing those, you could change the speed of the motor. Now, this lathe has had all of the tubes and everything else taken out of it. That was done previously, even before my Willie, who got it, had it. And they put in a contraption. I'll show you down there below. And I'll be honest with you, I'm not very impressed with it. It doesn't appear to be working very well. And that was really the issue with this. It is electrical. The lathe works, but it doesn't work well the way they set it up. It has some speed control to it, but it does not have the full range of speed control that you should be getting out of a Monarch 10EE if it is set up with proper electronics. And that's one of the problems I think a lot of people do when they do these conversions, when they come in here and do some type of conversion, taking the original equipment out because it quits working, whether it's the older motor generator set like my older 10EE has, or whether it's this tube set that was in this one. You can go buy an off-the-shelf DC drive. A DC drive is very similar to a variable frequency drive, where basically you put, you know, alternating current power to it, usually just single phase. You can do three phase. And in the magic inside that box, it spits out the DC current, and you can change the voltage or whatever going to the motor. The issue that they have with the DC drives is that, at least with this particular lathe, is that the voltage for the motor that's in this one is 230 volts. Which is kind of a not so common voltage for DC motors. And most DC drives are designed for either, I think it's 90 volts or 180 volts. So you can make them work, but you don't get that full range of speed control. You don't get that full level of torque that you got with the original setup. Now, there are some guys out there that have come up with ways to do a modern retrofit on these things where you get all that, but it's a little bit more complicated than just go buy a simple DC drive and throw it on here. Now, a lot of guys out there are running the DC drives and they're perfectly happy with them and they do a good job. And yes, you can make them work. And I know personally people that have those set up on there, they're very happy with them. But to truly get the maximum utility out of the lathe, most of the off-the-shelf DC drives probably aren't really performing as they should. A lot of people, what they do is they just they take the DC motor out, they put a three-phase motor in there, they put a variable frequency drive on it, boom, you're in business. And yes, again, it works. And I know people that have that option, and it works great. But again, it has some disadvantages, mainly that you don't have that torque on the lower speed ranges that you do with a DC motor. Generally speaking, if you can keep the DC motor, if the motor is good in these lathes and you can keep it in there, it is a better option than some of the other options. And what I'm going to probably end up having to do this is replace the whole drive system in it. And let me show you what they got. I'm going to pull, there's a drawer that kind of pulls out down here on the end, and I'm going to show you what's in here right now. I'm down here on the floor on the back end of the lathe. The first thing I'm going to do is I'm going to point out this motor that's back here. This is the motor out of my other 10EE, which I think is a 1942 model. It's a little bit older than this one, but this is the DC motor that came out of it. And while this motor is different than the motor that's in here, it's made by the same company. It's a Reliance motor. It's a very similar motor. And one thing that's unique about this is there's this gearbox on the front. These lathes had a high and low range in them, where you could shift down to a basically a gearing in here that would give you an even lower range for slower speeds, or you would just run it straight off the pulley for the higher speeds. I think this motor could go up to like 4,000 RPMs maximum. So, you know, you can get some pretty high speeds on there. But if you're working in the lower ranges, you could go down and have a little bit more speed control at those lower ranges by shifting the gearbox. You know, if you just swap it out and put a three-phase motor in there, there are some people who will basically take the guts out of these motors and run a shaft up through it and put a three-phase motor in there and keep the gearbox. Other people just take the gearbox out and basically they lose the option to putting the back gears in. But you got challenges when you swap these motors out, because this is pretty much proprietary to this Monarch, this whole front end up here. And to keep this thing truly working, you almost need to keep these motors going. Again, the motor that's in here is a little bit different. The motor part is, it's got the same gearbox, but the motor's a little bit smaller, same horsepower. I guess it's just, you know, 20 years or 10 years, 15 years later, whatever, the motors were getting a little bit smaller. Let's show you what's going on here. So in these lathes, they had a drawer that pulled out, and this is where all the tubes and the electronics were. And all that's been stripped out of this, and they have replaced it with this setup here. You got your power coming in. There's this big variac in here that changes whatever a variac does, but basically this allows for variable speed. And there's a big transformer, and you can't see the transformer. It's kind of up in here. There's a huge transformer that sits right here. And I believe that this is a rectifier here that converts alternating current to direct current, a bridge rectifier. So there's all this stuff going on in here. And it honestly looks like to me that they just kind of found whatever parts they had laying around the shop and threw this thing together. I don't know. But bottom line is that this setup, in my opinion, doesn't work all that great. And probably the biggest disadvantage to this setup is you do have variable speed by controlling this dial right here, but you have to come over here to open up the box on the end of the lathe and reach down here to change your speed. Not very practical. In the normal setup, there's a knob over on the lathe that you turned for the speed control, and there went to a potentiometer or rheostat or whatever in there that controlled that from the lathe controls. This is very impractical. The other big issue that I've had with this lathe is that there's a power box on the back. I'd put something on Facebook on this, and I really was posting more about just the electrical train wreck, more so than asking questions or whatever. But on the back of the lathe, there's the disconnect. It says 120/208 volt input, and 120 volts is just regular single phase power. It is single phase. 208 volts is kind of an oddball voltage, unless you're in an industrial setting and have three-phase power powering your building that's on a Y configuration versus a Delta configuration. Again, kind of getting down into the weeds, but on a certain type of three-phase system, the way that they tap into the transformer, the voltage across two hots, even though it's 120 volts to neutral, when you do the voltage across the two, is 208 volts. And I believe that's how they had this thing set up on, was 208 volts. My problem in my shop is that without putting a transformer in here, I really don't have a way to get 208 volts. Because if I take two of my 120 hots, put them together, I got 240 volts. And I found out, because I tried it, if you put 240 volts to this lathe, bad things happen. We got a little bit of smoking going on. Fortunately, I didn't do any damage to anything, or at least not any serious damage. I had a transformer. It was a control transformer that it didn't like 220 volts. I switched it over to 120 volts, which I can do, and things will power up and run, but just I don't have very much control over speed. It pretty much only works at 100%. And bottom line is I just don't think this setup's really going to work in my shop setup. And even if I do play around with the voltage and get it from 208 to 240, I still got the problem of this big rheostat down here, the big variac down here that you have to reach into the cabinet to do variable speed, which I'm just not a big fan of. So this is probably going to go away. So again, right now I have it plugged in to 120 volts, regular 20 amp outlet here in the shop. I'm not running it under any load. I imagine that if you were to put it under load, it probably wouldn't be enough voltage to really do, but it will run on it. I'm going to flip the power on down here. When I flip that on, basically I'm putting power to this whole contraption down here in the bottom. And then I got my power switch right here on this particular 10EE. There's a switch. You move it forward or backwards for reverse, and it spins up. So we're going to let it go in forward there. Now, again, in the current setup, I pretty much just have one speed because I have to run it at 100%. When I drop that variac down, it wants to kind of surge and do some weird things. I'm not really happy about all that. And even here, the RPM seems to be fluctuating. Right now, according to tachometer, we're running about 2,000 RPMs, which is honestly too fast for a lot of stuff. And I really can't get that RPMs down with the current setup. I imagine if I was on 208 volts that it probably would work better. But what I mainly was wanting to do here is just kind of test the machine out, check it out, see how it's working. So right now, we're going. I want to check my feeds out. On this, you got a forward and reverse lever on the apron. We put our feed in, and that's working. On the cross slide, put it in, it's working. Cross feeds work just fine. Now, if I want to switch over to threading, I need to do a couple of things. You flip this down and you can change your dial here to kind of put you into range. And I'm just going to pick one. It really doesn't matter. You got the letters over here. You find how many threads per inch you want. It tells you what combination. You got two knobs. There's an A and B up here, and there's a C, D, and E down here that you can turn and set. For threading, we need to flip a couple of knobs around here. Let me disconnect that. Yeah. All right, so first one we're going to flip is that one, and then we also need to pull this one over. There we go. And then we need to put that in threads. You got right hand and left hand threads. So let's get going again. You can kind of hear it surging. And eventually it's going to speed up here. Again, it's doing weird things electrically. But you got your half nuts here. Oh yeah, I got to put this kind of in a neutral position. And we're threading. So that looks good. So mechanically, everything seems to be going. We can go to the back gears. To do that, we move that knob right there, and you can see the speed has dropped down much lower when we go to the back gears. And then we can go back to the regular gears. There we go. So bottom line is that mechanically, I don't think we got any major problems here. Everything appears to be working pretty good. The motor. appears to be working pretty good. The weak leak on this lathe, again, is the electronics in there. And we're just gonna have to see about tackling that and coming up with a better solution. This one came with a Loris tool block. This is what is that, a BXA size, which I've got a bunch of tool holders. It's over on my Revette lathe, same size, so I've got tooling for this. Nice little lathe. Came with a 3-jaw chuck, and he had a couple of other odds and ends that he threw in as well. Just that kind of was with it, but what you see is kind of what you get here. It does not have a taper attachment on it. That was an option on these lathes. Another thing is that some of these lathes had what they call an electronic lead screw reverser, where you could use for threading. This particular model does not have that feature as well. Not a big deal. Actually, my older 10EE has a lead screw reversing set up on it. And I'm really kind of looking forward to getting that one going where I can play around with that. I've never worked on a lathe that had one of those. But bottom line is it should be a nice, good user lathe once we work out the electrical issues. So guys, what are my plans? I'm gonna attempt to do the electrical stuff on this. And part of that is it's an exercise because I know that when I get my other 10EE going, the one that I'm totally rebuilding, that I'm gonna have to tackle those challenges. So it'll be good practice for that and kind of work out the kinks and work out the bugs and get this machine done right so that it's a good usable machine. Now, do I need 2 10EE lathes in my shop? The reality is it's probably not. And at some point in time, I will probably part with either this lathe or the other lathe. I'll make that decision later on. You know, after I go through the full restoration, I will probably keep the one that's been fully restored, but we'll see. You know, we'll just kind of have to wait and see how all that goes. But I would really like to get this to turn it into a lathe that I can use in the shop in the interim. Now, you guys that watch the channel a lot know that I also have that Revette 1020S, which is a similar size machine made by another company. Again, a very high quality tool room lathe, very capable machine. Many would argue, or at least some would argue, that it's probably even a better built machine than the 10EE. And when you put them side by side and you just kind of compare them, I think it's a fair argument that the Revette is probably a little bit beefier, heavier duty, higher quality machine. One of the advantages that Revette has is it does not have the electronic drive system in it like this one. It actually has a Reeves drive in it to do the variable speed, and it's a mechanical system. It's a lot less foolproof, I guess. You know, there's things that can go wrong mechanically in the Reeves drive, but it's all mechanical instead of electronic, so the average person can work on it. Whereas you need to be an electrical engineer to figure out some of this stuff down here. Maybe exaggerating, but still, you gotta know electronics, and that's not really my specialty. But at the end of the day, I'm a Monarch guy. I love my Monarch lathes, and I'm probably gonna keep one of the 10EEs, and again, the Revette is probably gonna get sold at some point in time. In fact, I'd probably let it go whenever. In fact, if you're interested in a Revette 1020S, you can talk to me. I would seriously consider letting it go even right now. But my goal is I want to get this one working until I get my other one working. And then we'll make a decision on which one I'm going to keep, which one I'm going to part with, et cetera, et cetera. Willie told me, the guy that gave me this lathe, he said I can do with it whatever I want to. He says if I want to keep it and use it, keep it and use it. If I want to pass it along to someone else, pass it along, sell it, you know, take parts out of it and part it out, I'm not going to go with that option. He actually gave me that option, but I think this lathe is in good shape. Like I said, there's very little apparent wear on it. I haven't done any measuring or testing or anything, but normally you can feel a little ridge on these ways at the top if there's wear in them. And you know, down here in the area where you would expect to see the most wear, there's just nothing there. I mean, I don't think this machine has seen that much use. He said he thought that it came out of a General Electric plant, I think, up in New York. It was probably in a maintenance shop. It wasn't in a production setting. So, it's very likely that this machine didn't get a whole lot of use over the years, relatively speaking. That's what it kind of appears like. But we got to sort out the electrical stuff. But there you go. I've been doing a lot of homework on the electrical stuff. I've been spending a lot of time over on the Practical Machinist forum. There's lots of information there on people who have done various retrofits to these 10EEs. There's also lots of opinions over there. That's one of my things about discussion forums that I get frustrated with, is that, everybody that does anything, there's 20 people that are going to tell them they're doing it wrong. It's kind of like having a YouTube channel. Every time I do anything, I have a bunch of people telling me I did it wrong. At the end of the day, if it works, it works. It doesn't matter. But I will agree that there are better ways and worse ways of doing something. And I think with the conversion on this, there's easy ways you can do it. There's hard ways you can do it. There's better ways. There's worse ways. There are ways that have advantages and ways that have disadvantages. And I've been doing a bunch of reading over there, trying to sort through the chaff and figure out what I need to do. And I'm probably going to be enlisting the help of some outside resources on this, because again, electronics just is not my area of expertise. If there was an off-the-shelf kit that said, hey, connect these wires, here's a wiring diagram, I can do that all day long, but I don't understand the electronics of what's going on. And, so I think you almost need some of that working on a problem like this. But anyway, wanted to share the new machine, give you guys a chance to look at it. I'm real excited about it. Can't wait to kind of get some of this stuff sorted out. It may be a little while. It may be this winter before I really have a chance to focus on this. I got some other projects that I need to get out of here before I kind of jump on this. But it is going to be something we'll work into the queue and get going hopefully sooner than later. And with that, guys, that's going to be a wrap. As always, thank you so much for watching. Please subscribe to the channel if you haven't already. Thumbs up and comments, greatly appreciated. Hit the bell icon to get notifications when new videos are posted. Big thank you to all my supporters out there on Patreon, PayPal, people that send stuff into the shop. Couldn't do everything we do without all your help. And with that, guys, we are going to sign off. As always, again, thanks for watching.